There's an undiscovered planet hiding in our own solar system, so far from Earth that no human eye has ever seen it. A mystery scientists have been chasing for over 100 years. We call it Planet 9, a massive sphere of ice and rock, at least twice the size of Earth and potentially 6 times its mass. Planet 9 orbits the Sun far beyond Neptune and Pluto, reaching distances up to 500 times greater than the space between Earth and the Sun. Unlike every other planet in our solar system, it travels on a tilted orbit of roughly 16 degrees. And that orbit is so vast, one single lap around the Sun could take up to 15,000 years. Detecting something like this is, for all practical purposes, nearly impossible. We thought we knew everything about our own solar system. Turns out we barely knew the surface. You might be wondering, if we can't see it, how do we know it's there? That's a completely fair question, and the answer lies at the heart of one of the most powerful methods in the history of astronomical discovery. It all started with Uranus. The 7th planet from the Sun, Uranus was discovered in 1781 by a man named William Herschel. He wasn't out looking for a new planet. He was studying comets with a telescope he built in his own backyard. At first, he thought Uranus was a comet, until he realized it was something far larger. That's one way to stumble onto a planet, but it's not exactly a repeatable method. And Herschel wasn't even the first person to see it. Uranus had been appearing on star charts for decades. It was simply too faint and moved too slowly for anyone to notice. But as scientists continued tracking Uranus's orbit, they noticed something strange. At certain points along its path, the planet would speed up or slow down, as if something out there was pulling at it. This is technically called perturbation, and it's a clear sign that an object in space isn't moving entirely on its own. An external force is pushing or pulling it. So what was perturbing Uranus? To find the answer, we have to jump to 1846. 2 astronomers, Urbain Le Verrier and John Couch Adams, independently concluded that the strange behavior of Uranus had to be caused by an undiscovered planet somewhere in the outer solar system. Using orbital mechanics and classical mathematics, they calculated exactly where that planet should be. A German astronomer named Johann Galle then pointed his telescope precisely to the coordinates Le Verrier had predicted. And within just a few hours, he became the first person to observe Neptune, the 8th planet from the Sun. This discovery proved something fundamental. Mathematics is a far more powerful tool for finding new planets than blindly scanning the sky with a telescope. Scientists began searching for more unexplained perturbations, and they found a subtle wobble in Neptune's orbit. That became the starting point of the hunt for Planet 9, a search that reached a new chapter in 1930 with the discovery of Pluto, which was at the time considered the 9th planet. This is also a good moment to introduce an important concept: observational bias. Astronomers went out looking for a new planet beyond Neptune, found something, and assumed it must be what they were searching for. It wasn't. Pluto appeared large and bright through a powerful telescope because of its high reflectivity. But it was actually quite small, nowhere near massive enough to perturb Neptune's orbit. And that wobble in Neptune's path? It turned out to be a measurement error, but none of that stopped the search. It just made the work harder. And that brings us to where we are today. Over the past 30 years, the deep solar system has seen a flood of discoveries in a region called the Kuiper Belt, the same neighborhood where Pluto lives, but also home to an astonishing number of icy and rocky objects. To put it in perspective, the Kuiper Belt may contain thousands of Pluto-sized bodies, most of them still unnamed and unclassified. And beyond those, there are at least 100 billion additional objects 1 kilometer or larger in diameter. Now, the suspected location of Planet 9 lies far beyond even the Kuiper Belt. But if it's really out there, the gravitational influence of such a massive body should be visible in the behavior of distant Kuiper Belt objects. And in 2016, that's exactly what 2 astronomers from the California Institute of Technology believed they had found. Mike Brown and Konstantin Batygin noticed a strange cluster of objects at the outer edge of the Kuiper Belt, all of them grouped in long, tilted orbits pointing in the same direction. They didn't look like they were orbiting the sun randomly. It looked as if some external force had lined them up, and as more Kuiper Belt objects were discovered, the pattern became harder to ignore. Some were orbiting over and under the solar plane. Others were moving in the exact opposite direction of every other orbit in the solar system. Just as with the discovery of Neptune, these scientists concluded that all of these strange movements had to have a single, large source. To test this, they ran a computer simulation. It started with the solar system in its early chaotic state, right after the planets formed, and then ran two scenarios. One that included Planet 9 and one that didn't. The result? When Planet 9 was included, all of the distant Kuiper Belt objects aligned exactly as they appear in our solar system today. Based on this study, the existence of Planet 9 carries a probability of 99.6%. Of course, the simulation doesn't explain why such a large planet would be sitting so far from the Sun in the first place. The Kuiper Belt exists precisely because there wasn't enough material in that region to form a full planet, which means Planet 9 must have come from somewhere else. And that somewhere else could be an entirely different star system. Scientists call this a rogue planet, an object ejected from its original star system and left to drift freely through space. Our Sun's gravity may have captured one of these wanderers billions of years ago. Another possibility is that Planet 9 began forming much closer to the Sun, somewhere between Saturn and Neptune, and was flung outward before it could grow into a gas giant. Not ejected far enough to become fully free-floating, but just enough to get trapped at the very edge of the Sun's gravitational reach. In either scenario, Planet 9 would be an extraordinarily dense world, a compressed mass of rock, metal, and frozen material, like the core of a planet that never fully formed. If you can imagine something more dead and frozen than Pluto, that's exactly what this would be. Now, for a planet no one has ever seen, we seem to know quite a lot about it. So where exactly is it? Finding Planet 9 is not even as straightforward as finding Neptune was, and that was already hard enough. The object we're looking for may be 15 times farther from us than Neptune. It's also smaller and far less reflective. No bright, gas-filled atmosphere to bounce light back at us. Planet 9 is almost certainly invisible to anything except the largest telescopes on Earth, and even with those, it's still like searching for a needle in the world's largest haystack. There's also the possibility, of course, that Planet 9 doesn't exist at all. Remember observational bias? Brown and Batygin at Caltech were specifically looking for signs of Planet 9. So naturally, that's what they found. But are there other explanations? Some of them are arguably even wilder than a hidden planet. A few researchers have suggested that a tiny primordial black hole could be drifting through our solar system, its enormous gravitational pull distorting the orbits we're observing. Yes, you heard that right. These are called primordial black holes. Theoretical objects that may have formed in the very first moments after the Big Bang, when the densest regions of matter skipped the stellar phase entirely and collapsed straight into black holes, wandering through the universe ever since. And here's a question I want to leave with you. I won't tell you what I think, but I want to hear from you. What do you believe Planet 9 actually is? If primordial black holes exist, they're most likely not in our solar system. But just like Planet 9 itself, this theory is neither confirmed, nor disproven, nor ruled out. There are simpler explanations too. Perhaps Planet 9 is following an orbit that covers an unusually wide range. Or perhaps gravity behaves slightly differently at extreme distances from the Sun, and what looks strange to us is simply nature doing what it does. After all, every prediction we make about gravity and orbital mechanics is still governed by laws that Isaac Newton established in the 17th century. And Newton never observed anything beyond Saturn. It's entirely possible he missed some details, or that the laws, as we have them, aren't fully sufficient. Because we can see so much of what's nearby, we assume we understand our solar system. But the further out we look, the more we realize how much we don't know. The good news is, that's about to change. The Vera C. Rubin Observatory. Look it up. It is the most technologically advanced telescope on Earth, equipped with the largest and highest resolution digital camera ever built. Its motorized system can scan the entire visible sky once every 3 days. Rubin came online for the first time in 2025, and its mission is to map the night sky over and over again for the next 10 years, building, in effect, a time-lapse video of everything in space. We won't have to hunt for strange objects anymore. They'll reveal themselves through the data. New comets, new stellar objects, near-Earth asteroids. And if Planet 9 is really out there, we will find it. The universe gives up its secrets slowly, one discovery at a time. And every discovery is a reminder of how deep science runs and how relentless human curiosity truly is. From here, all that's left to do is watch and wait. New mysteries, new events, and perhaps answers to questions that have been hiding for thousands of years. Soon, everything hidden will be visible. Thank you so much for all the support and interest you've shown this channel recently. It genuinely means a great deal. Drop a comment on this video and make sure to explore the other content on the channel as well. Until the next one, take care of yourselves.